Welcome back to the remaining part of chapter number 17, resistance and current, the Ohm's law and resistivity. Yes, electric power. The rate at which the energy is consumed is called electrical power. Power P is equal to I. I is the current flowing through the circuit. V is the potential difference or the voltage. We have Ohm's law. V is equal to I multiplied by R. So if I substitute first, P is equal to I multiplied by V, the voltage. Right? So V is equal to I multiplied by R. So I could write here I square R. The power is equal to I square R. R is the resistance. Each electrical and electronic component, it offers some sort of resistance to the flow of the current in the circuit. If you have electrical heater, it has some value for the resistance. If you have compressor, if you have, anything, any device, it will have some sort of resistance in the unit of ohms, volt, and current in ampere. So this is one I square R, done. Now, how I got this second one? So again, P is equal to I multiplied by V. So I is equal to V over R. So V already I have here. So V square R. The powers, another expression for the electric power is V square over R. This one which I showed it to you here. The unit of power is watt by the letter W. Right? So, as I told you that power is equal to energy over time, right? So energy is equal to this and time this. So power is equal to energy over time. If I need energy, I will take T to the other side. So P multiplied by T is equal to energy. So electrical energy, the electricity we use at our homes, once you pay the electric bill, they call the electrical units. So 1 unit of electricity is equal to 1 kilowatt hour. Okay, 1 kilowatt hour is called 1 unit, right? And you have the rate for for 1 unit. So how many units you consume? For example, 1000 units you consumed or 500. You simply multiply that number of the units with the price for the 1 unit, 1 kilowatt hour, right? So 1 kilowatt hour, basically watt is the unit for the power. Joule is the unit for energy. So joule per second is equal to watt. You know that from chapter number 5, work and energy. Right? So joule per second is watt. Okay? Now 1 kilo means 10 raised to power 3 watt 1 hour. I'm using the SI units. Okay, watt is the SI unit for the power, and power multiplied by the time. Time is 1 hour, so 1 hour is equal to 60 minutes, and 1 minute is equal to further 60 seconds. So you would get, this is what I put it here, question mark for you by the way. So 3.6 10 raised to power 6 joule, right? So this is how we convert this much of energy in joule is equal to 1 kilowatt hour. So this is one unit of electricity. Okay, 1 kilowatt hour is equal to 1 unit for the electricity. Right. So the cost of electric energy consumed we can calculate, as I told you. What is the unit, how many units you consumed, multiplied by the rate for 1 unit, the price for 1 unit, you can find out. Once you have some sort of machine, you are giving it some power to get some work through some operation. That is the input power. And the work you get, the power consumed, how much power you need to complete that work, and there is some wastage, like in friction and the heat energy in the conductors and the wires and the machine parts. You cannot get 100% output from the input power provided to that machine, for example. So we here define to electrical power and electrical energy efficiency. How efficient is that machine? What is its power efficiency? Now, it's defined as the ratio of the output divided by the input. Okay, so this is the Greek letter eta, which is the efficiency, power efficiency. Efficiency is equal to P out or P in multiplied by 100. So you would get percentage for the efficiency. Similarly, you can find out for the energy efficiency. Let's move to the last example of this chapter. Yes. You see, now we are going to apply the electric power concept and calculate the cost of power usage using kilowatt hour. A circuit provides a maximum current I at an operating voltage V. How many 75 bulbs. So how many bulbs mean you have to find out the number of the bulbs. It's very clear. A part, number of bulbs you have to find out, right? Can operate with this voltage source. First of all, let's calculate the total. You see, in your home or in your office, you may not have just the electrical bulbs like in this example. You may have air conditioners, you may have fans, you may have heaters, you may have geysers, and the computers, many others. But to make the things easier at your level, we are focusing only on one item, which is the number of bulbs. Okay, so let's calculate the power total. First of all, total. We multiply by I. Right. We how much? I current. You get 2.4 watt total power. Right? Now, you see, the total power is utilized, is used to power of one bulb multiplied by number of bulbs. So total power is utilized, number of bulbs multiplied by what is the power of for one bulb, so you will get the total power consumed. Now, let me call this N, and this is P for 1 is equal to P total. So I need the number of bulbs, N, P total, or power for one bulb. So total, I just calculated here. Or power for one bulb, how much? 75. Okay? Power for one bulb. This is given to you. So 75. So you get finally the number of bulbs, 32. It means that you have 32 bulbs. One bulb power is 75 watt. You consume total power this much, which is equal to the total. Second part, B part of the question. At $0.120 per kilowatt hour. So one unit, keep in mind, 1 kilowatt hour means 1 electricity unit. And that price for 1 unit is $0.120. How much does it cost to operate these bulbs for 8 hours? Right? So, first of all, let's calculate the energy consumed by these bulbs. Okay, we have power multiplied by time, right? P is power, total by the way. P is power total, and T is total time. So time is 8 hours, and total power is, this is watt and this is hour. Keep in mind, you have to make it kilowatt hour because 1 electric unit is kilowatt hour. So to make it kilo, 1 kilo is equal to 10 raised to power 3 watts. Keep in mind. So I have to divide, now instead of watt, I would write kilowatt, right? And 8 hours. So kilowatt hour mean units. So this is what I need. If you don't convert it into kilowatt, you will be having wrong answer because you need one electric unit which is equal to 1 kilowatt hour, so must be kilowatt and hour. Hour already we have here, this is watt, so divide by 10⁻³ to convert it into kilowatt. So finally you would get, here, if you don't mind, can I delete all these things here now? Okay, so I come here, energy is equal to kilowatt hour are the units. How much? 119.2, sorry. Okay, so the cost will be equal to 19.2 multiplied by the cost for 0.120. You would get dollar, how much? 2.30. That's it. That was the last question, and please don't forget to subscribe this YouTube channel because you will be getting in real time the updates whenever I am uploading, so you will be getting spontaneously, inshallah. Have a nice day and good luck.